Whipping Physics.
Today we're working on Unit 4, Net Forces. For this problem, it's an FRQ about inclines. First, we're going to draw a general free body diagram. Class, can anyone tell me why the normal force is not straight up and down with gravity?
Force normal is not straight up and down because it's always perpendicular to the surface in the free body diagram.
Good, Jared. Now we're going to draw the force perpendicular to the surface, which is straight down, even with the force normal. This force perpendicular will be used to calculate the force acting on in the parallel direction. Now we have a right triangle, which will be used to find the magnitudes of both the force parallel and the force perpendicular. Now we're going to use the 15-degree angle to calculate the magnitude of force parallel to the surface. To find that, we will be using SO, Ka, Toa. Some old hippie caught another hippie tripping on acid. That's an easy way to remember it. So for this specific problem, force parallel, or the magnitude of force parallel, equals the sine of 15 degrees times force of gravity. Force of gravity equals negative 200 newtons, which is then multiplied by the sine of 15, which is 0.258. This makes the force of parallel equal negative 51.7. Now we're going to calculate the force normal. The force normal is equal to the force perpendicular. We will use the same strategy we used earlier with the force parallel to calculate the force perpendicular. However, in the force perpendicular, it is cosine of 15 times the force of gravity, which is still negative 200 Newton. Gives us the force perpendicular, which is equal to the force normal. However, it won't be negative, so it'll just be 193.1. Okay, class. Now, how will we find the force of friction using all the things we've calculated?
Mu equals force of friction divided by force of normal. So when you manipulate the equation, force of friction equals mu times force normal.
Good, Jared. The force of friction equals the mu, or coefficient of friction, times the force normal. Therefore, the force of friction equals 28.97 newtons. Now that we have all of the forces we need, what should we do to calculate net force?
In this diagram, the net force is calculated by adding normal force plus the force of friction. Another name for normal force is the force parallel in this particular free body diagram.
The net force is equal to the force parallel, 51.7, plus the force of friction, which is negative 28.9. This gives us 22.7 newtons. How do we calculate acceleration now that we have the net force and the mass?
Net force equals mass times acceleration. So to find acceleration, you must rearrange the equation. So it is acceleration equals net force divided by mass.
Jared, that means that the acceleration equals 22.7 over 20. This comes out to 1.135 meters per second squared.